This video covers topic 14.4, which is solving quadratic equations by factoring, day 2. So again, to refresh our steps up here, in order to solve, we set things equal to 0, we factor completely, we set each factor equal to 0, and we solve each factor. Problem 1 has been started for us. So they ask us to find the solutions to the following quadratic equations. We have this equation, but we do not have an equal 0, so we move 18s by doing the opposite operation. So we bounce over here, s squared minus 18s plus 81 equals 0. From here, we solve by factoring. So s squared and 81 go in the box. Looking for something that adds to negative 18, so negative 9, factor it out. I notice that this is a perfect square trinomial, so s minus 9 squared equals 0. From here, we set the factor equal to 0. In this case, we only have 1 because the same factor is repeated, so s minus 9 equals 0. And we solve. We add 9 to both sides, so s equals 9. Now, normally with a quadratic, we have two solutions, but for this example, we only have one. That means that one solution on a quadratic bounces instead of crossing. Normally, we have two, like -7 and -3, and it crosses through. But if you know you have a quadratic, but you only have one solution, it means that you still have a U-shape that bounces at your solution. So that's how we know this is what it looks like. It is a positive graph because a positive leading term. So my s squared is positive, my graph is positive. It opens up, it's normal, it's a U. So from here they ask us for the axis of symmetry for the graph. The axis of symmetry is related to your vertex. Your vertex in this case is related to where it bounces. So it bounces at 9, meaning 9, 0 is my vertex. Because my vertex has a 9, my axis of symmetry is x equals x from the vertex, so x equals 9. So problem 2, they ask us for the zeros that satisfy this solution. So we have 3r squared minus 12 equals 0. We have an equal 0, so we will go straight to factoring. So 3r squared minus 12 equals 0. Both of these are divisible by 3, so I will factor out a 3. And I'm left with r squared minus 4. I will take this and factor. If you remember the formula chart or the formula for this, then you are allowed to use that. If not, use the box. R squared minus 4. My product is negative 4r squared. My sum is 0 because there is no r listed. So in y equals, I have negative 4 divided by x. I click on my table and I'm looking for two numbers that will cancel out. So 2 minus 2 will cancel out and give me 0. So my factors are 2 and minus 2. From here I factor out my GCF and I have my two factors. So r plus 2, r minus 2, and my GCF of 3 from the beginning. I then take each factor that contains the letter r and set those equal to 0 and solve each one separately. So r plus 2 equals 0. I move the 2 through the opposite operation, and one of my solutions is at negative 2. So I'll draw 2 tick marks, and I have a solution at negative 2. And then my other factor was r minus 2, so I add 2 to both sides. So my other solution is at a positive 2. Now this graph has a positive r squared term, or a positive first term, which means my graph will be positive or U-shaped. I know that it has to go through both of these and look like a U, so this is a pretty good estimation. My axis of symmetry for the graph, the axis of symmetry, is always halfway between your two solutions. So if my two solutions are 2 and negative 2, directly in between 2 and negative 2 is 0. So my axis of symmetry is x equals 0. Problem 3 on the back asks us again for the x-intercepts of this equation. 52 equals negative 2n squared minus 30n. So I need an equal 0. That's my first step. So I'm going to move the negative 2n squared and the 30n and put it over here. So 2n squared plus 30n plus 52 equals 0. Now that I have an equal 0, I'm ready to factor. These all share a 2, so I will factor out a 2. Remember, when you factor it out, you are dividing. Now that I have what's in parentheses, I will take that and plug it into my box. So n squared and 26. My product is 26n squared. My sum is 15n. So in my calculator, I put 26 divided by x. I click second table, and I am looking for two numbers that add to 15. 2 plus 13 would give me 15, so I put 2 and 13. From here, I factor out my GCFs. So my factors are n plus 2 and n plus 13 equals 0. So I am done factoring. From here, I take each factor, set it equal to 0, and solve. So when I solve, I subtract 2 from both sides and get that n equals negative 2. So that's about here-ish. And then for the other one I solve, and I get negative 13, so that's way out here. My leading term is positive, so this is going to be a U-shaped graph. And then I am asked to find my axis of symmetry. Now, I didn't draw tick marks here because they are pretty far apart, so I'm going to show you another way to find your axis of symmetry. There's a formula on your formula chart that says axis of symmetry. I'm going to show you exactly, or tell you exactly what it says. It says x equals negative b over 2a. So, if we remember back to day 1, standard form is ax squared plus bx plus c equals 0. So for the b and the a, I need the first and second numbers. And for this, we use the original equation. So negative b would be negative 30 divided by 2 times a. A would be a positive 2. Now the cool thing is I can put that in my calculator exactly like I see it. So remember, if we go alpha, oh, this one doesn't do it, sorry. Alpha y equals, or you can do parentheses and do negative 30 divided by 2 times 2. So I can put that my axis of symmetry is negative 7.5, or I can click math enter, and it tells me it is negative 15 over 2. So if you don't want to count between the ticks, you can do negative b over 2a. Sometimes it's hard to count through the ticks, and we're about to see an example like that. So problem 4 asks me to find the roots of 24x squared minus 8x equals 0. I already have the equal 0, so I can go straight to factoring. 24 and 8 both share an 8. X squared and x share an x. So I will divide this out. 24 divided by 8 is 3. X squared divided by x is x. Negative 8 divided by 8 is negative 1. X divided by x cancels, and we have equals 0. Now, because I do not have any x squared terms, because I have an x here and an x here, and remember I need 2 answers, so 2 x's, I can take each factor and set it equal to 0. From here I will solve, so I divide both sides by 8 and x equals 0. For this one, I add 1 to both sides, so 3x equals 1. And then I divide by 3, so x equals 1/3. So x equals 0 is right at 0, 0. X equals 1/3 is going to be right next to it. It's very, very tiny. My leading term is positive, so this looks like a normal U. And then they ask me for the axis of symmetry. Now the axis of symmetry, here, I can't really count ticks because you'd have to think about what is halfway between 0 and 1/3. And not a lot of us are good at doing fractions in our head. So what you can do instead is use your formula, negative b over 2a. So in my original, I have a and b. So negative b over 2a. Okay, so notice b was already negative, so that's why I have 2 negatives here, because it's the opposite of b. If I simplify this, I get 8 over 48. So in my calculator, 8 divided by 48 is ugly, so I click math, inner, inner. And my axis of symmetry is x equals 1/6. And I apologize, on problem 3, I forgot to put the x equals. So to find your axis of symmetry, this is a lot easier than trying to find the halfway point between 0 and 1/3. So, last problem. Area of a rectangular room is given by the equation L squared minus 5L equals 66, where L is the length of the room. Find the length in feet. So the first thing I need to do is make an equals 0, so I will move 66 to the other side. So I will have L squared minus 5L minus 66 equals 0, because my zeros, or my 66 cancel. Now, I do not have any GCFs, so I can go straight to the box. L squared, negative 66. So my product is negative 66, L squared. My sum is a negative 5L. Oh, well, I apologize. I did not know that was still up, but I actually need it right now. So in y equals, I will put my product of negative 66 divided by x. Second table and search for the sum. I'm looking for negative 5. I only look at whole numbers, so I skip decimals. Ooh, 6 minus 11 would give me negative 5. So from here, I take out my GCFs. So my factored form is L plus 6, L minus 11. I take each factor and set it equal to 0 and solve. Minus 6, minus 6. So length is negative 6, or plus 11, plus 11. Length is 11. Now remember, we talked about on 14.3 with real world situations, length and width, you cannot have negative answers. So my just for my real world answer, my length is 11 only. However, you can still graph this. My length is 11. And then another possible solution would be -6. My leading term was positive. So something ugly like that. And then we are still asked for the axis of symmetry. So -b over 2a. So negative, my b is -5. 2a, my a is invisible 1. Negative negative is a positive. So x equals 5/2, or as a decimal 2.5.